This is Unit 3, Lesson 1, Expressions and Equations. We're going to start off with some definitions. And you're going to need to be able to use the words that we define below, but I don't want you to try to memorize exact definitions. You simply need to understand what they mean and be able to use them. You probably know some of them already. The first term is a variable. A variable is a symbol, usually a letter, that's used to represent an unknown quantity. That is, it's a letter that stands for some amount that we don't know yet. A constant is a fixed number. In other words, it's basically a plain number that doesn't include any variable. It's just a plain old number. An expression. An expression are numbers, variables, and operators. And operators are things like adding, subtracting, multiplying, and dividing. You can include parentheses in there too. So numbers, variables, and operators that are grouped together that show the value of something. So here's an example of some expressions. Those are numbers, there's variables, there's operators in there. These are not expressions. And you can see why they're not expressions. This first one has an equal sign in it, so you cannot have an equal sign in an expression. The second one also has an equal sign. The third one has an inequality symbol, so none of those are considered expressions. An equation is simply two expressions that are set equal to each other. That might be a new way of thinking about what an equation is. So here's some examples of equations, and let's think about it in that way. This part on the left, 2x plus 3y, that's an expression taken by itself. And on the other side, 6, that's considered an expression, because an expression, if you recall, has numbers, variables, operators, but it doesn't have to have all of those things. It can have any of those things. So 6 itself is actually considered an expression, and so these are two expressions, and they're equal to each other. Here's some examples that are not equations. This first one you can see, and the second one, there's no equal sign in there. So it's not an equation because it has to have an equal sign in it. And the last one's got an inequality symbol, so that is not an equation either. An inequality are two expressions that are being compared with an inequality symbol. So you can see we have the same situation. We've got an expression, and we're comparing them with an inequality symbol. These are not inequalities. The first one's got an equal sign, so that's no good. The second one and third one, those are just expressions, no inequality symbol. A term. A term is the product of a number and one or more variables. Well, what does that mean? First of all, product means multiplication. So it's multiplication of a number and some variables. So another way you can think about it is the terms are the parts of an expression that are separated by addition and subtraction. So let's look at some examples. All right, here's an expression 5n plus 3. So you can see that there's a 5n part and a 3 part that are separated by a plus. So 5n and 3 are the terms. Now you can see that I've included the plus with the 3 because that plus is separating the terms, but it also goes with that 3. So we're really considering it a positive 3. So 5n and positive 3 are the terms of that expression. The next one you can see we've got a positive 4a, a negative b, and a positive 5c. So those are the 3 terms of that expression. Now the last one has only one term because the 4 and the x and the y are not separated by adding or subtracting. They're all being multiplied together, so that is just one single term. A coefficient. All right. A coefficient is the numerical factor when a term has a variable. What does that mean? It means it's the number part of a term that has a number times a variable. So let's look at some examples. All right, look at that first expression, 7xy. The 7 is the coefficient because it's the number part. And it indicates quantity. There are 7 of these things that are called xy's. In the second example, 3 and 6 are the coefficients because there's a term with an x variable, and the 3 is in that one, so there are 3 x's. And there's a y term, 6y, so there are 6 y's. So the 6 is also a coefficient. Now why is negative 12 not a coefficient? That's because negative 12 is a constant. It's just a plain number. There's no variable there. So only 3 and 6 are the coefficients in that expression. Now how about that last one? X to the third. Well, I don't see a number there. But how many are there? Oops. There are my coefficients. Well, they were supposed to have arrows happening. All right, let's look at that last one. There's 1 x to the third. We don't need to write a 1 because that's implied, and it's more simple to write it without the 1, but we know that it's there. So 1 is the coefficient in that x to the third term. All right, example 1, I want you to state the number of terms in each expression. So at this point, pause the video and complete those 4 problems and start it up again when you're done. All right, let's see how you did. It helps to circle. That might help you out. You can see that there are 2 terms in this expression. In B, there are 1, 2, 3 terms. In C, there are 4 terms. And in D, that's just one big term with all those numbers, with the coefficient of 6 and the 3 different variables all multiplied together. No adding or subtracting in between, so it's just one term. All right, example 2. I want you to try this one as well. I want you to answer each question based on the given expression. So I want you to do part A, B, and C after you pause the video. All right, let's take a look. List the coefficients. Well, there are 3 terms here, and the coefficients are 7, 5, and -9. Make sure you didn't list that as 9. It's actually a -9, and it's important to list it that way. The variables are x, y, and z. Now, even though the x is to the 4th power, we just need to indicate that there is an x variable involved. Is there a constant? Answer is no, because you can see that all of those 3 terms have variables involved, so there's no constant. All right, next one, list the coefficients. The coefficients here are 8 and 6. That's because 8 goes with the A and 6 goes with the B. The variables are the A and the B. Is there a constant? Yes, there is. In this case, that -7 is a constant because there's no variable that goes with it. And again, it's really important that you list it as -7. All right, next part, C. Oh, there's our answer. Is the coefficient 0 or 1? It's a 1, because if it were 0, 0 times those variables would be nothing. So it wouldn't be listed at all. So since there's no value there, we know that it has to be a 1. All right, example 3. Daniel has $58 in his piggy bank. He gets a job mowing lawns, and he charges $15 per lawn. So what we'd like to do is write a variable expression to describe how much money he has in his bank. Well, how much does he have? It depends, right? It depends, because the amount in the bank will vary depending on how many lawns he's mowed. So we're going to use a variable to represent that information. How many lawns did he mow? Well, it could be different depending on how many he's mowed. So that's why we are going to use a variable to represent that. So our very first step is to define our variable. We have to tell what our variable stands for. So we're going to pick a number. We're going to pick a letter, and it can be your choice. Often I like to use a letter that has to do with the thing that it's standing for. So what we don't know is how many lawns he has mowed. So I'm going to use N to stand for the number of lawns he mows. So you need to write that down as your first step. And then the second part is to write the variable expression. So let's think about it. How much is in the piggy bank? Well, we know he starts out with $58, and then he's going to have $15 for every lawn that he mows. So if he mows 1 lawn, it's another $15. If he mows 2 lawns, it's 15 times 2, or $30. 3 lawns would be $45. So what we know is we're going to take 15 and multiply it times how many lawns that he's mowed. So we're going to say it's $58 plus it's 15 times how many lawns he mows. So our variable expression is 58 plus 15 times N. Let's try another one. It's 80 degrees in Miami. Each hour, the temperature cools by 5 degrees Fahrenheit. So we want to write a variable expression to describe the temperature in Miami at any time. Again, we don't know how many hours have gone by. So the temperature is going to be depending on how many hours have gone by. So we're going to first define our variable, and I decided to make it an h this time. It depends on how many hours have passed, so h is going to stand for the number of hours that have passed. So let's think about what happens. Starts out 80 degrees. And then, because it's cooling, the temperature is decreasing, it's going down. So I want to subtract 5 degrees for every hour that goes by. So I would write 80 degrees minus 5 times h. 5 times every hour that goes by. All right, example 5. Give this a try. I want you to pause the video. I want you to define a variable and write a variable expression to describe how many apples Martin has on any day. All right, let's see how you did. First, defining the variable. Often x is used in variable expressions, but you can pick any letter you want. I like to choose x because that's the one we use most frequently in algebra, but you can use any letter in your expression. All right, now we write the variable expression. What happens? He's got 24 apples, but then he eats 2 every day, so it's going to be going down by 2 for each day that goes by. So we've got 24 minus 2 times x. All right, example 6, same deal. Pause the video, give it a shot. Let's see how you do. All right, let's see. First we're going to define our variable. I'm using x again to stand for the number of hours that Janine skates. So she first has to pay $13 just to get into the park. So no matter what, she's paying $13. But then she's also going to pay more money depending on how many hours she's there, $3 for each hour. So she is going to be spending $13 plus 3 times however many hours she spends. All right, that's it. Put your note sheet in your binder so you'll have it for class tomorrow. See you then.